Explain like I'm 5. How do computers know what zeros and ones actually mean? Okay, so I know that the alphabet of computers consists of only two symbols, or states 0 and 1. I also seem to understand how computers count beyond 1 even though they don't have symbols for anything above 1. What I do not understand is how a computer knows that a particular string of ones and zeros refers to a number, or a letter, or a pixel, or an RGB color, and all the other types of data that computers are able to render. A lot of you guys hang up on the word know, emphasizing that a computer does not know anything. Of course, I do not attribute any real awareness or understanding to a computer. I'm using the verb know only figuratively, folks. I think that somewhere under the hood there must be a physical element like a table, a maze, a system of levers, a punch card, etc., that breaks up the single, continuous stream of ones and zeros into rivulets and routes them into, for lack of a better word, different tunnels? One for letters, another for numbers, yet another for pixels, and so on? I can't make do with just the information that computers speak in ones and zeros because it's like dumbing down the process of human communication to mere alphabet. The computer on its own doesn't know what any of it means. We know what it means. And we know where we stored the data. So we can write a program that reads and interprets it in the correct way. A lot of that can be automated, because you can tell what type of file something is from the header. But again, that's our way of interpreting the header, which is just a binary string, to mean different file types and such. The computer is, at a basic level, just following the instructions that we give it to manipulate the data, and use that to display things on the screen, for instance. They know what each string of zeros and ones means because we tell them what it means. And by we, I mean the people that designed the operating system. Ones and zeros are in a sense on and off. More in electronics it's high voltage and low voltage, where if for example voltage is more than 5V, the components perceive as 1 and below that as 0. This high and low voltage states are cycled. So a cycle of 2 high voltage is perceived as 3, a number that's generated using binary digits of 0 and 1. Programmers program the meaning of those zeros and ones. They don't do anything and they don't mean anything until they are defined by hardware and software engineers to mean something and do something. The pixels on your display are meaningless until someone defines some meaningful system for displaying information using the pixels. And someone seeing the displayed pixels agrees that they appear meaningful. The easiest answer? You tell it when you're programming in type languages. At least you tell the computer, hey, this memory location has a 32-bit integer in it. Or use the value stored in this memory location as the intensity of red in this pixel, etc., etc. Everyone else is also right, of course. But this is how it works at a high level. Most people when programming or operating computers don't tend to think about the logic gate or transistor level. I'm getting in late, but I don't think the top answers are what OP is looking for. The answer is context. In the ones and zeros language of computers, the letter A is defined with the exact same pattern of ones and zeros as the number 65. When a calculator app uses that pattern, it knows that it's a number. When a texting app uses the pattern, it's a letter. Programmers define what the interpretation should be in the particular context. Well, the answer is that it knows because we tell it what to expect. Think of memory as a long sequence of ones and zeros. And we break it into groups, bytes with addresses that start at 0. When the computer starts, it knows what address to look at first, and what to expect their code to start running to boot up. When running any program, we give it the starting address for that code. And when the code needs to look at data, the code supplies the data address and a description of the data that the programmer decided look. Here, you'll find an integer. The initial zeros and ones in a sequence can tell the computer what the remaining symbols represent. Example: 0 image, 1 sound. So 010100011011010 is an image. And 100,111,010,110 is a sound. Of course, that's a gross, disgusting even simplification. Computers set extra bits that interpret the other bits. Metadata. X. Data stored as a signed integer could have its first bit represent negative or positive. Each computation step will already be informed what type of data it's about to use. A practical example is a SQL database where each field is set as a type, like text or bool. I built a simple calculator in Minecraft with the help of a YouTube video. Learned a lot about binary. The computer knows nothing. It just manipulates its memory and registers the way program instructions tell it to. It's up to programmers to write the software so that this results in something meaningful. For computer A or B makes no difference. It's just some pattern of bits written to some memory address so that some pixels light up on a screen. So what you're missing is something called representation theory. It's not really zeros and ones, it's various versions of presences and absences. As for how to interpret it, it's up to the particular program. If it's word processor, the number 220 might be a character, but if it's a graphics program, it might be a color or a particular sound. You see, the idea is that in different contexts the different digital combinations are interpreted differently. So if you opened up a video file in a program expecting to represent a number, you'd get a very large number instead of a movie. A 1 is when there's a lot of current running through a component. A 0 is when there's not a lot of current running through a component. That's pretty much the physical element. You are making a mistake we all make as humans. Humanizing. You watch an octopus grab something, and you think he is grabbing it with his tentacle hand. Actually, what the octopus is doing is leagues further from what we do when we grab something with our hands. Same with the computer. You wonder, how does it know what 1 and 0 means? When actually it's just electricity impulses navigating circuits and unthinkable speeds. It's simply wired to process impulses and lack of impulses. It doesn't know shit. They know because apart from the main information, they also store a lot of additional data to provide context. And all that context data is standardized. For example, when you save a picture to a .jpg file, there's not only the ones and zeros of the pixels themselves, but also a lot of parameters that indicate that the content of the file is indeed a picture. What size it is in pixels, if it has transparency, what program camera was used to create the file, etc. It doesn't. It's all just numbers. The programmer is the one who knows. We put the sequence of numbers 72, 101, 108, 108, 111, 32, 87, 111, 114, 108, 100, 0 into a certain memory location. We assign that to a variable. The variable is a string type and the compiler knows this. But if we're using a language that allows this, we can easily just consider each to be a number. Or we can consider it 3 RGBA colors. A language like C will just accept that the data type is whatever you tell it it is. They don't. It's a way for humans to write complex things down. It's like that multiple choice book we read the other night. Except this one has a lot more choices. Now go to bed, it's late. Computers don't know what the zeros and ones mean. They just blindly follow our instructions. It's convenient to personify computers, because that abstraction makes them easier to talk about. But computers aren't thinking.